tayong bago project. Oh. Ano naman yan? Ha? Ba? Ito ay tinatawag na NAND Gate using transistor. Ano naman yan? Ito yung ginagamit ito sa mga switching circuits. Isang uri ng switching circuits. Ano naman ang gawa niya? Ha? Dito makikita natin kung paano gumawa ng NAND gate. Ha? Ito, power LED, kulay red. Output. Dalawang input LED, yellow and blue. Switch, yellow sa yellow, blue sa blue. At mga discrete components. So siya ay merong transistor, resistor. Anong gamit niyan? Ha? Tingnan natin. Gamitan natin ng supply. Power bank. Power bank, 5 volts. Diba? Connector. Ayan. Umilaw na yung power LED, yung output umiilaw. Ano naman ang gagawin mo dyan? Ha? Itong mangyayari dito, ha? Pag pinindot ko yung switch, may mangyayari dyan. Teka. Initially, yung output LED umiilaw na. Pag pinindot ko yung unang switch, di ba? Umiilaw yung input LED. Ibig sabihin, pinindot ko yung switch. Pero yung output, buhay pa rin. Pangalawang switch, blue. Pinindot ko, umiilaw yung input LED. Ibig sabihin, napindot ko na yung switch. Buhay pa rin yung output LED. Diba? Kung sabay. Wala na yung output LED. Diba? We now come to our diagram for our project. NAND gate using transistor. Okay? For the circuit, we have this power LED. Once we powering this circuit, the LED turns on, this power LED. We have these two transistors connected this way, or some sort of cascading transistor. The input switch 1, switch 2, input LED, color yellow. Input LED of the second switch is blue. That is blue. Okay, blue, yellow, blue. And then we have this base resistor for biasing. I use 12.2K resistor to make sure that our transistor is totally saturated at the output side. So once it is Switching on, it will saturate or serve as a closed switch. Initially, our output is on. Why? Because current flows to the resistor 120 ohms and to the LED, green, the output LED. And these two transistors are open because current will not flow into the transistor because of the switch. Two switches are open. This is normally open switch, push button. So once we press the switch 1, we are having this an input of 1. It means the switch 1, the input 1 is on, causing the current to flow into the input LED. Once we press the switch 1, color yellow LED turns on, and the input side of the transistor turns on because it injects a current to the base with this 12.2K biasing resistor in order not to burn this transistor, causing this transistor to turn on, but the output remains open. Why? Because the current will not flow into the collector to emitter, and then to ground because of this transistor. So when we press the switch 1, it will not make this output LED to turn up because our aim is to turn this output LED, to turn off this output LED. Since this is a switching circuit, we need to use a truth table. A truth table for the NAND gate. Let us see the truth table for the NAND gate. For the switch 1, A. Let's make the switch 1 A and then switch to B. So we have an input of switch A and a switch B. And the output is Y. We use Y. This one is the output Y. Okay. And then, initially, for the truth table, when switch A is 0 and B is 0, it means we did not press the switch. That's why it is 0. The output is 1. Why is it 1? Because this output LED turns on. Okay? And then if our switch A is 0, again, this is 0, and we press the switch B. So we press this switch. What is the output? This output. It will not turn on. Still. Why is it 1? It will not. Bakit ganun? It will not turn off. 0. Still, it is still 1. Right? The output LED still turns on. If we press the switch 1 and then 0 for the switch 2, still output LED is 1. Okay, and if we both press the switch, 1 and 1, we have this 0 output because the current flows into the base of the transistor, causing this transistor to turn on, and also the current flows into the base of this transistor, causing this transistor to turn on, and the current flows directly to the ground. R5, then collector to emitter, then to the ground, bypassing this output LED. So it will become 0. The moment we press the switch together, it will turn off this output LED. So the truth table is not pressing the switch, the output is 1. It means output turns on, output LED turns on. If we press the switch 2, switch 2, and we did not press the switch 1, still the output is 1 or remains on. And we press the switch A, 1, and then 0 for B, not pressing the switch B, still the output is 1. If we both press the switch, the output is 0. It means this LED turns off, 0, because the current flows directly to the ground by passing this LED. So it no longer turns on. Okay? Every time we press the switch, LED, input LED turns on. We have this current limiting LED for each input LED. Okay? So this switching circuit is called a NAND gate using transistor. And the truth table is this. We need to use a truth table to know the condition of the circuit. We usually use in digital electronics. So if we both press the switch again, this transistor turns on, and also this transistor turns on, causing the current to flow from collector to emitter of the first transistor, and then collector to emitter of the second transistor. This transistor will saturate, and it has 0.7 volts. It means it is saturated. It serves as a closed switch also with this transistor, 0.17 volts, and it is fully turned on. And for our project, we have now this NAND gate truth table. So this is now the formal truth table of a NAND gate. Also, we have the symbol. 2 input AB with an output of Y. Just like in the truth table with a bubble into the output side. Because the NAND gate is the inverted version of an AND gate. So the symbol looks like an AND gate with a bubble to the output.